Hello again. This is Math 1120 coming to you from the College of DuPage, and the title of this lecture is Midterm Solutions and Such, and this is posted on October 18th of 1923. And as always, please be attentive while watching this video. You can pause, rewind, and stop, and you should use this as a study aid. Okay, so here was problem one. We surveyed a random set of drivers. These are experience in years, and these are the monthly automotive premiums. And I asked a bunch of questions about correlation coefficients, slopes, and intercepts of a line of best fit. Question about, is the line good enough to use? What was the percentage of variability that explained in the premium based on the regression equation. And then I ask you to use this line, and the line is good enough to use, to predict the premium per person with 20 years experience. Okay, so here are the answers. I used Excel for most of these, and the equations that I used for Excel are shown down here, so that helps. The concept question was, it is good enough to use, but here's the reason it's good enough to use, because we have to look in our table, and we're looking in our table. There are 8 data points, ordered pairs, and the cutoff thing is 0.707. So you see, if the absolute value of our value, which was 0.749 and change, is greater than that, which it is, we're good enough to use. That's the explanation that you should have used. And the rubric was -4 for each wrong answer, up to 20. Here was a Yoder family reunion, and the ages were recorded as they arrived, so these are not in order. I asked a whole bunch of questions about the maximum, minimum, median, 25th and 75th percentile. That's the 5-number summary that we studied. And I also asked you about the mean and standard deviation. This was the sample standard deviation. I asked about the modes, and I asked a concept questions. What happens if we return in 5 years? What will be the standard deviation then? Okay, these are the correct answers. The rubric was -2 for each incorrect answer, so it was important to get the right answer. And let's see, so you should have sorted the data, and when you sort the data, the top score will be the minimum and the bottom score will be the maximum. So the max was 61, the minimum was 2. Now the median, you had to realize that there were 27 numbers, and I did say that you needed to use Tukey's characterization of median, not some formula that you found in Excel. And so what you do is you say 27 plus 1 is 28, divided by 2 is 14. So you count down 14 elements, and that gives you 31. And for the 25th percentile, that means that you pick the 14th one, so there are 13 above. 13 plus 1 is 14, and 14 divided by 2 is 7. So the 7th number will give you 13, and the 7th number on the other side of the median is 38. And the modes, there were 2 modes, both 31 and 2 appeared multiple times. And there's no change in the standard deviation, because if you added 5 to everything, the spread would be the same. Here is the tool you could use to sort it, and you do need to sort it on a problem like this. And here are the Excel equations where Excel equations were used. In many cases, I just sorted the data and looked at the data. Here's number 3. I gave you some data in a contingency table and asked you to answer these questions. So what you always do is you add up the rows and add up the columns to answer the question. So the probability of strawberry is there are 35 divided by 137, and that gave you this, this number here. The probability of vanilla given that you're male, well, if you are male, that means there are 71 of you, but 32 out of 71 liked vanilla, so this is 32 over 71. The probability of female given that you like chocolate, well, if you like chocolate, there were 58, and of those, the females were 37, so 37 over 58 is this number. And then I ask is, are these independent? What happens is a way to answer that question is, does the probability of female given chocolate is the same as the probability of females? Well, here we calculated the probability of female given chocolate, and if these are independent, those two things are going to be equal. So we have that number, but the probability that you're a female, you go over here and you say, well, there were 66 out of 137, and you get this number. Since those two things do not equal, these are not independent. And the rubric was -5 for each wrong answer. Here was a child, a doctor visiting a sick child. You can read it here. The rubric was full credit for the correct answer and -10 for a wrong authentic answer. If you said the answer was pie or something, that would have been wrong, and that would have been -20. This is Bayes' theorem that we studied in class. Okay, and so I told you should draw a diagram. It was 90% have the flu and 10% have measles. But if you have the flu, 10% will get rash and 90% will have no rash. If you have measles, 95% will get a rash and 5% will have no rash. So the question I asked you was a Bayes' theorem question. I said, what's the probability you have measles given that there's a rash? And so these are the two states of nature where there is a rash. And so those compose the bottom. Those are independent. We multiply along each of those directions. And then the probability that you had measles is up here. And so that is 0.1 times 0.95 divided by all of this. Here's the Excel where I did the calculation, and here's the correct answer that you should have had, 51 and some percent. Number 5 asks, how many different words, including nonsense words, can you make using all the letters in this word effervescent? So you count, there are 13 letters, so that's a 13 factorial in the numerator. There are 5 E's, so we're dividing by 5 factorial, and there are 2 F's and 2 C's, so we divide by that. Okay, so you see we can cancel the 5 factorial with the bottom 5 factorial here, and so we only need to go down to 6 in the top, but then we're dividing by 4, and we can divide the 4 into the 8 and getting 2. But otherwise, you're multiplying all of these numbers together, and this is what you get using Excel. And so that is the answer. That's the correct answer that you should have had. Here was a counting problem. You can pause and reread this, and you have it on your test. But anyway, there are all of these questions. Okay, these are the correct answers. And here are the Excel formulas that I used for the first 3. The last one is a little bit more complicated. The rubric was -5 for each wrong answer. That was because each problem was worth 20. And so that's what you have. Some more detailed discussions of how you arrived at those considerations for A, B, C, even D. And so, studying these could be useful. This was a confidence interval problem. A poll found 329 out of 763 adults said they would travel to outer space. And you were supposed to do things about the point estimate, the margin of error, and a 99% confidence interval for this proportion. And so here are answers. This is the value for p hat. This is the value for the margin of error. And this is the confidence interval. and you can, and this of course is p hat minus e. This is p hat plus e. And the formulas that were used down here in Excel, and so there are 3 answers, and the rubric was -6 for each wrong answer. This was a normal distribution problem. Scores on the GMAT are normally distributed with a mean of 527 and a standard deviation of 112, and I ask about various probabilities, and the third one asked about central limit theorem. Okay, so what you get is the answer to A would be 0.5953 or something close to that. The answer to B would be 0.711, or not 711, would be 711, or some number close to that. And the answer for C, of course, you know that the standard deviation with the central limit theorem changes. You divide by the square root of n. We had 49, so the square root of 49 is 7. And so that would be 16. So these are the correct answers. The rubric was -6 for each incorrect answer. In closing, I'm giving you, as you know, a second chance midterm, and the quality of mercy is not strained. It's an opportunity for you to use this to study and redeem yourself. I am going to, if you scored lower than you think you're able to. So this is a good thing, and you should take advantage of this. I'm going to pick the 5 problems, and more about that later. In closing then, God bless you all, and take care. Hope to see you in class.